Today we're going to use chi-square to test our hypothesis, and the formula for chi-square is just shown here, which is a chi-square is called the summation of observed minus expected squared divided by the expected. When you are using a chi-square, you are just trying to test how fit the observed value is related to the expected value. Here is my example. Let's do it. My example says here that Mr. James carried out a survey of 1,600 cars at a random and got his result as follows. Hertz 441, Space 404, Diamond 402, and Club 353. He claims that there is no difference between the cars. Now you have to test the hypothesis that there is no difference between the cars. How are you going to do it? Let's do it now. First step you're going to follow is state your HO and your HA. Your HO says there is no difference between the cars, and then your HA says there is a difference between the cars. You know that your alpha is 0.05. The second step, now you're going to choose your critical value from the table. How are you going to do that? For looking at the graph here, you see that when you're using 0.05 as shown here, you are 95% sure of what you're going to do. Now the region shaded here, black as you're seeing, is the rejection region. That is, you're going to reject any value outside here to here, you're going to reject it. Any value fall on the shaded portion, here is the region. This is the region of rejection, so you reject the hypothesis. Now, when you do that, go into your chi table, you discover that at 95% sure of 0.05, you have 7.81. Now, the next step now is to calculate your statistics. From the question there, we say that diamond has, the heart has 441, the space has 404, and your diamond has 402, and then your club has 353. See it on the table now. When you observe here, you can see that the heart has 441, and like that you see from the question, and a total of 1,600 cars. Now, how are you going to get your expected? Now, to get your expected, just use a simple formula, which is n divided by 4. N is the total number of the observation divided by the total number of outcome. So the number of outcome is just 1, 2, 3, 4. So you just put your 4 here. When you divide it, you get 400. That is your expected for all the cars here as you see in the table. So you're now going to minus your expected from the observed. How are you going to do that? Just take 441 minus 400 like that. So you say 441 minus 400. Do away with the 400 here, you get 41. Here, do away with the 400, get 4. Do away with the 400, get 2. Do away with the 400 in this, where we get minus 47. Now you are going to square the value, just get it, you get here now. So how are you going to do it? You are going to say that 41 square gives you 1,681. 4 square gives 16, 2 square gives 4, and then minus 4, 7 square gives 2209. So we're going to divide it by the expected. You know the expected is 400 now. So your observed minus expected square from the heart here just 1681. So stage 1 divided by the expected is 400, you get 4.20. Then from the 16 like that, you get 0.04. Here we get 0.01. Here we get 5.52. Now, going to the summation of the kite value you just calculate here, you just get 9.77. Now, you're going to make your decision. Your decision here just to reject HO if chi value, the value you calculated in the table here is greater than or equal to the value tabulated, which is critical value here, we get 7.81. Now, you can conclude now that you will reject the HO because the value calculated from the table is greater than the critical value you got here. Now, from your first step, you say that there is no difference between the cars in the null hypothesis. and there is a difference between the cars in the alternate hypothesis. Now you reject your null hypothesis. In the area you're accepting the HA because there is a difference between the cars. Thank you guys for watching my video. See you next time.